e-commerce analytics demo, we explore a comprehensive knowledge graph that interlinks orders, products, sellers, and more to offer a multifaceted view of transactions. Starting with specific orders, we expand the exploration to include associated products and sellers, dynamically filtering by delivery status to highlight key data points directly on the visualization. This approach enables detailed insights into e-commerce operations, enhancing decision-making, and improving customer service strategies.
Currently, PuppyGraph can be launched in two main ways. The first way is through Docker, which is going to allow you to run PuppyGraph anywhere that you can run Docker. Secondly, you can also launch PuppyGraph through the AWS Marketplace, and soon you'll be able to launch PuppyGraph through the GCP Marketplace as well. Today, I'm going to show you how to run it in Docker. So for Docker, you can simply come to our PuppyGraph docs, click Getting Started, launching PuppyGraph in Docker, and then, following our step-by-step tutorial here, it's just a couple steps. First, you'll need to make sure that you have Docker installed. Then, after Docker is installed, you'll then start a PuppyGraph container using this command. Just one note is that this command means that when your container is stopped, based on this --rm flag, this is going to completely remove the PuppyGraph instance. If you want to keep the instance so that you can start and stop it, just remove this -rm flag. Of course, if you want to make further tweaks to this run command, you can do that as well as needed. Once you run this command, the PuppyGraph image will be pulled down, and then the system will boot up. Once you've got PuppyGraph up and running, you can then proceed by logging into it. The default credentials will be PuppyGraph as the username and PuppyGraph123 as the password. Our next step, once we've logged in, is to upload our graph schema JSON. Now, there's other ways to do this as well. We can also use the create graph schema functionality, which is going to allow us to connect to a data source and then use the UI to design the graph schema. Or if you don't have a schema, you can also use one of our example schemas as well. That being said, today what we're going to do is use a JSON file that contains our catalog connectivity details, as well as how to map the data from our SQL data source over into PuppyGraph. Now, what exactly does that JSON schema look like? Well, here's an example where we're connecting to a single catalog, even though PuppyGraph can actually connect to multiple catalogs. Here we're connecting to a tabular instance, which is going to host some e-commerce data for us. So we're going to have stuff like the name of the catalog, the type, and then metastore information, which is going to include stuff like credentials and the type and the URI of where this data is going to actually reside. After we've defined this, we'll then come to the vertices array, which this is going to contain a bunch of objects defining what our nodes are going to look like. So for example, we have a customer node that is mapped from the tabular data source and tells us exactly which table it's coming from, as well as some meta fields associated with that map table source. Then we have attributes for this node. So this is the data that we're going to pull from that map table source. So here we have stuff like zip code or customer city, customer state. As we scroll down, we can see that we've got order, geo, product, seller, payment, review, and then to actually connect all that data together, we need to define our edges. So to give you a quick little example here, we might have a customer to order edge. You can see mapped table source here. Similar to what we did with the node, this is going to tell us where this data comes from, but additionally, you're going to see a from and to meta field. So this is going to be where the edge comes from and where it is going to. And then here you can see what nodes this is going to connect. It's going to connect customer nodes to order nodes. And then you can also add attributes to these edges as well. As you can see, we've got some additional edges like order to geo, order to product, order to seller, order to payment, seller to order, seller to geo, and finally review to order. And this is going to construct our schema. So when we come back to PuppyGraph, we'll want to upload the schema file. So you can see that I've chosen my file. Then I'll click upload, and this is going to upload that schema to PuppyGraph. Now that we've uploaded the schema, we can see this in a visual format. So we can see all of our nodes here. So seller, geo, order, payment, customer, review, and product. And as you can see, when I go over top of them, you'll be able to see all of the incoming and outgoing edges from each of these nodes. We can see the complete list here, and we can see that
nodes, we have 7 types of nodes, and then 8 types of edges, all which came from our JSON schema. Now that we've got the schema there, we can instantly go to querying that underlying data source as a graph. So for that, I'm going to come over to query, and you can see here that we've got a gremlin query, which is going to allow us to run gremlin queries and then see a visualized representation of the query output. Then we have the gremlin console, which gives us a CLI version of our ability to query the underlying data in gremlin. Then we have a Cypher console, very similar again to the Gremlin console. And then if you want to run stuff in graph notebooks, you can also do that as well. For our purposes here, I'm actually going to show you how to run everything within this Gremlin query interface. The first query that I'm going to run will be one to figure out the city with sales ranking in the top 10. So here you can see we have g.v has label order, and then we're checking order to seller has label seller. And then you can see here that we're actually going to pull the seller city plus seller state, group, order, unfold, and then limit to the top 10. And then we're going to output the location and count. So if I run this query, we can see here that I get my output, which shows the location and the count. So this is the number of orders that have been placed in each of these cities. As you can tell, we're using a Brazilian e-commerce data set here. So all of these are going to be located in Brazil. Now to further this, we could also look at which product categories are contributing to these top 10 sales. So here you'll see that I'm doing g.e has label order to product, and then I'm grabbing the product category name, doing a .group count by product category name. And when I run this query, let's look at what the output looks like here. So if I click expand, I can see that my category is here. And then I can see the count, which is the number of sales that include this specific category of product. Now, let's say I wanted to look at some historical data. Next, I want to take a look at the top sellers by sales in the year of 2017. That's exactly what we're going to do here with this query. And you can see that we're looking between 2017-0101 to 2018-0101, and we're going to be looking at the seller ID and the total sales of that seller. You click the play button here, and we can see here that we now have the seller ID as well as the total amount of sales that they have. Now, what if I wanted to be a little more specific and understand the top selling products in Sao Paulo? That's exactly what I can do with this query here. So I'll do a g.v and look for customers where the customer city is Sao Paulo, and then find those products. And then I'm going to show the product ID and the sales count. If I click run, then I can see my result here, which is the product ID as well as the sales count for that product. And you can see that I'm showing this in descending order of the top products. Lastly, let's take a look at the seller's rating. And we're going to do this based on sellers having no less than 10 reviews, and they need to have at least an average rating of greater than 4. And we can see right here that we do a g.v has label seller. Then as we move through the query, you can see that I'm filtering based on reviews where they have to have greater than 10 reviews. And you can see that I also need them to have an average score of greater than 4. Now, if I run this query, you can see my output here. And now I can see the seller's ID as well as the rating on each of the reviews. Now, what we could also do is use the visualization feature within PuppyGraph, which is going to give us a graph visualization interface that we can then use to explore this data without querying. In this particular instance, we can see here that I've got order and the products, payments, reviews, the seller, the customer, and the geo of this particular order here. If I click on it, you'll see that I can see some of the attributes a little closer as well. I can see that the label is order, and I can see that the order status is shipped, as well as the purchase timestamp. As I go further out in the visualization, you'll see that more and more data will continue to load. These here are all the individual orders associated with this particular seller. Again, what you're going to get here is a more traditional graph visualization approach that you can use to explore the data without querying. Now, what if we had some queries that we wanted to persist? Here, we can do that through the dashboard. By default, we're going to see a couple of tiles that will be shown in the dashboard, including a vertex count. So this is going to tell us how many nodes we have in the data set, an edge count, how many edges we have in the data set. We can see vertex labels, so this is going to tell us how many nodes of each type exist in the data. Then we can see vertex samples, and underneath all of these is a graph query. So if I click, for instance, on vertex here, you can see that I'm doing a g.v.count. The display type is text. There's also the graph display type, which is what we're seeing here under graph samples, as well as table, which is what we're seeing behind here. If I exit out of this, we can see that in this graph sample, which the underlying query is this here, we can explore this data by clicking on the node or on the edge, and it will tell us each of the attributes associated with it. Now, jumping quickly back to our query interface, let's run that same query here, and we can see here in the middle that we have all of our customers, then their associated orders, and if we straighten this out a little bit, we kind of look a little bit closer at all of the details of this order. Customer, order, we can see the order's seller, we can see the payment, we can see the product that they purchased with that order, and we can also see the geolocation of that order. Clicking on each of these will give us the attributes of that node. We can see product here, we can see payment, and the seller. Now, if I right click on this, you'll see that I can do query and view properties, expand with edge label, or expand with all edge labels. I'll click expand with all edge labels, and now I can see even further into this graph data. So here's my seller, and here are all the orders associated with that seller, as well as the geolocation of that seller. If I wanted to know more on a particular order, I can click it, and if I want to explore even further, I can right click and once again do expand with all edge labels. Then I can see that order's customer, product, geolocation, the review associated with that order, and the payment associated with that order. You'll also see on the left-hand side here that every time that I interact with this interface, the corresponding query is then populated in the display on the left here. Coming back to our dashboard interface, let's actually create a tile within this dashboard. For that, I'll click the plus button, then I'll click the edit button here. Let's then do top 10 cities by sales, then plug in our query, and then select the display type as table. Now, additionally, we can also rename the columns that are going to be output if we want a different column name mapping. I'll click submit, and here we can see that now I have this query persisted to my dashboard. This is great for saving queries and making the graph data easy to interact with for folks that may not be as comfortable with querying, or if you just want your data all in one place. When I come back to this dashboard, you'll see that that query still stays there, and you can add as many queries as you'd like to this dashboard. Now, with that, we've covered the basics of exploring your SQL data as a graph with PuppyGraph. For more information on how you can get started with PuppyGraph, go to www.puppygraph.com.